का जो वीडियो पोस्ट किया है वो आपको नासा का वीडियो आपको दिखाऊंगा। तो लाइव स्ट्रीम में जल्दी जल्दी ज्वाइन कीजिए और चैनल में तो चैनल को लाइक और सब्सक्राइब कीजिए। चलिए मैं चलता हूँ, आज के नासा से रिलेटेड वीडियो आपको इन्फॉर्मेशन मिलेगा। देख सकते हो टोटल 2026 में टोटल सोलर एलिप्स नासा का है, ठीक है। नासा लाइव कवरेज है 12 टोटल सोलर एलिप्स 12 अगस्त को आपको पोस्ट किया गया नासा के माध्यम से, ठीक है। मैं अभी चलता हूँ, वीडियो को प्ले करके दिखाता हूँ। जल्दी जल्दी लाइव स्ट्रीम को ज्वाइन करो, ठीक है। आज के सेशन में ये 2026 कैसे पता किया कि इतना सोलर बिल है। आज के लाइव स्ट्रीम में जल्दी ज्वाइन करो। चैनल में नहीं हो तो चैनल को लाइक और सब्सक्राइब कर दीजिए और इन्फॉर्मेटिव वीडियो को मिलेगा, ठीक है। जल्दी जल्दी चैनल में ज्वाइन कीजिए और जल्दी लाइव स्ट्रीम को ज्वाइन करिए। नए हो तो चैनल को लाइक और सब्सक्राइब कीजिए।
अरे खाके चावल यहाँ घाटा
चांद पे कैसे पहुंचते हैं नासा, ये सारे इन्फॉर्मेशन लेके आते हैं नासा। चलिए अब मैं चलता हूँ अपना।
She gets some really beautiful photographs over the mountains to the west. Now, the situation in the U.S.
The sun influences everything we experience on Earth. Earth is so perfectly positioned to experience this.
Totality hits.
This amazing phenomenon that is so rare throughout the universe.
This is a great time to learn more about our own star and how it affects our daily lives.
Instant chills. I burst into tears.
There's no other feeling like it. It's insane.
Everybody should be watching. Hello and welcome to NASA's live coverage of the 2026 total solar eclipse. We're at NASA's Goddard Space Flight Center, and over the next hour or so, we'll be tracking the eclipse as it races across the North Atlantic and Europe. A total solar eclipse occurs when the moon moves between the sun and Earth and completely blocks the face of the sun, casting a temporary shadow on Earth. People located within the moon shadow, also known as the path of totality, will experience a total solar eclipse. The sky will darken briefly as it withdraws from dust. So, weather permitting, people in the path of totality will see the corona, the sun's outer atmosphere, which is normally hidden by the bright face of the sun. Today's total solar eclipse will sweep across Greenland, Iceland,
Of opportunities for really beautiful photographs. And then as the eclipse progresses and that number disappears, West Africa will also get an opportunity to see a partial eclipse, that number shadows that slide up. And as we zoom up, Now, before you run outside
Please
to
live
look at
stream
your
को like करो
eclipse
जल्दी
that's
जल्दी
happening
फटाफट
right now,
बहुत
we
ही
want to show you a short video
बेस्ट
about how to
इंफॉर्मेशन
observe
दे
this
रहा
eclipse
नासा
safely.
जो 2026 का अगस्त 8 अगस्त 2026 का इंफॉर्मेशन डायमंड रिंग फेस 5 क्लासेस और सनलाइट ह्यूमन फाइनल स्टेज सर्किट सेट to learn more about ellipse safety.
If you'd like to find and explore the animated eclipse maps yourself, like the ones Ernie was referencing, safety instructions, and much more about today's eclipse, head to science.nasa.gov/eclipses. So next, I'd like to introduce our first guest here in the studio. We have Dr. Callie Corrick, who is one of NASA's heliophysicists, who studies the sun and its effects across the solar system. And she's also studied the sun's corona in great depth. Thank you so much for helping us kick off today's coverage. It's great to have her join. So let's talk about why we don't always see eclipses on Earth. We've got this awesome model here called an Ori. So using this, can we talk about their orbits and why we don't see it every month?
Yes, so here we have the sun, the moon, and the earth. And as we move, we can see that the moon is not exactly on the same line that we have with the sun. So the earth can view the sun pretty well, but when we get it to about here, we can see that sometimes, maybe a little further, sometimes it lines up perfectly so that we're able to have that eclipse. And that's when we have that eclipse. So that 5 degrees off ends up not having eclipse every new moon.
Okay. And so today's eclipse will travel across Europe for the first time since 1999. Can you tell me, why does that region not experience eclipses as often? And what is it that makes this eclipse unique?
Right, so this eclipse is unique because of the fact that it's near sunset. It's also the fact that Europe doesn't get as many, just simply as to the location, and any place on Earth, really, it's about 300 to 400 years between the time you get eclipses. So there's a lot of ocean on the Earth that it just doesn't go over land. Plus with the angle, it tends to move very quickly and pass in and out, so they don't get a lot of eclipses. And again, it's super special being near sunset, so being able to see a sun setting, being eclipsed, it's going to be really awesome photos.
Okay. And I've also heard of eclipse seasons. Can you talk a bit about that?
Yeah, so an eclipse season, when an eclipse happens like this, that lineup means that you're going to see the solar eclipse, so either a partial, annular, or total, and then you're going to see a lunar eclipse about 2 weeks later. So in about 2 weeks, we'll be able to enjoy the orientation where the Earth is actually casting the shadow on the moon and having a lunar eclipse. So that's the eclipse season.
Fantastic. And I know Europe is going to have another eclipse happening in 2027, which seems to be a lucky few years for that region.
Yeah, definitely lucky, and it's going to be a wonderful eclipse, and actually the longest eclipse of the century. So it's going to be 6 minutes and 28 seconds. It's a very long one, great for scientific investigation.
Wow. And so eclipses can occur somewhere on Earth roughly every 18 months or so. So why is it that NASA continues to study solar eclipses? Because every eclipse is a little bit different. The sun changes as it rotates changes in its 11-year cycle. The Earth and the area of the Earth that it covers is different. So we make sure that we study it each time. Fantastic. Thank you so much, Kelly. So throughout today's conference, we'll be joined by other NASA experts like Dr. Kelly Corrick, who can answer any of your questions that you have about solar eclipses, the science we're doing, and all the other activities we're hearing about today. You can ask your questions in the chat on YouTube, Facebook, Twitch, and Instagram, or tag @NASA wherever you're watching. We also have questions we want to ask you today. So if you want to head over to NASA's Twitch or Instagram stories and take a look at the poll we've got for you, you can participate and answer those questions. And so before we go on, I just want to point out that you may have noticed a clock counting down in the upper left corner of today's show. We'll have 2 different countdown clocks displayed over the course of the next hour that will let you know how close we are to the first instances of totality in the telescopic views we had in Iceland and Spain respectively. Those are the 2 locations where we hope our telescope partners will be able to capture the best views of the sun being totally eclipsed by the moon. We're tracking totality in Reykjavik, Iceland at 1:48 p.m. Eastern Time or 5:48 p.m. local time, and that will last about a minute or so. And then we're going to set our sights to Leon, Spain, totality there at 2:28 p.m. Eastern Time or 8:28 p.m. local time, and the eclipse there will be about 2 minutes long. So there's a lot of science taking place during those fleeting moments of totality today in Iceland, and we have experiments on the ground and in the air. And in the view you're looking at right now, there's a camera that will be capturing the view of the sun's corona when it's time for totality. When totality hits in Iceland, the planes are going to be chasing the moon's shadow for as long as they can. They're going to be studying the sun's corona where the skies will hopefully be clear up there. The plane took off from Keflavik Airport about an hour ago, and then we're going to be talking to the sightseers live from Iceland very shortly. Let's learn more about what it's like to be a NASA pilot in those eclipses.
For most people, a total solar eclipse lasts just a few minutes. But NASA's pilots find a way to make it last longer by trying to outrun the moon's shadow with an airplane.
The truth is, it's actually chasing us. We get out in front of it and let it overtake us. Once we're in totality, then we'll advance the throttles to max and try to stay in totality for as long as we can.
Making that happen takes extreme precision. Scientists calculate exactly where the airplane needs to be at each moment.
We do a lot of missions where being in the right point in time and space are critical, and this is one of them.
On Eclipse Day, the WB-57 aircraft climbs more than 50,000 feet into the stratosphere. That's above most of Earth's atmosphere, where clouds, dust, and water vapor could obscure the view.
Viewing an eclipse from 50,000 feet provides a really clear shot of the sun. And that allows scientists to have confidence that the data that they're seeing is from the sun rather than distortions from the atmosphere.
When the moon's shadow arrives, it engulfs the aircraft.
It's weird. Right where you're at is dark, but everywhere you see is twilight. The temperature in the cockpit drops, so it's very noticeable.
As the eclipse unfolds, the pilot keeps the aircraft on course, while the sensor operator fine-tunes the cameras, capturing every second of data.
You're very, very, very busy, and it's very high pressure because, of course, there's no do-overs. You only get one opportunity to get all these instruments trained on the right spot.
For the aircraft crew, it's a chance to witness one of nature's most spectacular events while helping scientists better understand our sun.
I'm sitting in the best seat in the house. It's pretty exciting.
Wow, what a job they have today. For this eclipse, the WB-57 aircraft has a camera on the nose of the plane that will be capturing images of the sun's corona. To learn more, let's chat with Principal Investigator Amir Kasmi, who is chatting with us live from Keflavik Airport in Iceland. Hi Amir, thank you so much for joining us today.
Hi Joy, it's a pleasure.
So firstly, how are you feeling right now? And can you tell us what experiment you're doing today?
Yes, well, feelings are mixed today because, as you can see behind me, the sky is not very great for those of us here on the ground. On the other hand, we have an airplane that's now cruising at 50,000 feet above sea level that's preparing to observe the eclipse in just about 14 minutes. And we are going to be imaging the solar corona with an instrument that has 4 cameras on board, with observations ranging from visible light through near infrared all the way to the mid-wave infrared, which we often refer to as the thermal infrared, to make new observations of the corona and learn all about coronal structure and dynamics.
What is it about the corona, the sun's outer atmosphere, that we're still trying to better understand?
Well, you know, we've known for about 100 years now that the corona is incredibly hot. It is millions of degrees hot, even though the solar surface is only a few thousand degrees. And we're still trying to understand exactly how the corona's magnetic field carries that energy up from the solar surface into the corona to heat it to those high levels. Our observations today will open new discovery space with wavelengths that are very rarely observed, that will allow us to apply physics models to better understand how that corona is heated. We'll also be looking at the structures of prominences or material from lower down that's kind of suspended in the corona that we're still trying to understand, especially in these infrared wavelengths where we don't have a lot of observations. And all of this will also help us to understand, of course, the sources of space weather that affect us here on Earth.
And so I know you've done this experiment and a similar one during the 2024 and 2017 total solar eclipses. What did you learn from those eclipses, and are you making any changes to your experiment for this eclipse?
In 2017, our first attempt at this kind of observation, we didn't even know what we were going to see. And measuring in the midwave infrared revealed new observations and new measurements that I think opened up the possibility of lots of future experiments to try to better understand this emission from the sun. In 2024, we flew an upgraded instrument, the same one that's flying this year. It has 4 cameras measuring across 9 different wavelength bands. And we learned quite a lot, although we're still analyzing that data. So I don't have any results to share with you right now, except to say that we saw some amazing structures, and it'll be very interesting once we complete our analysis.
Yeah, I'm looking
For
forward.
this year, we're flying the same... Oh, sorry, go ahead.
No, go ahead.
For this year, we're flying the same instrument, and we're not making any changes to it from 2024, except that we're applying all of the lessons that we learned from the prior flights, including being able to fine-tune the observing time and the observing procedures. And of course, we also now have our data analysis pipeline that's already made from 2024, which will allow us to combine this data with the data from 2 years ago to make new scientific measurements much faster than we were able to do in the past.
Thank you so much, Amir. I know the plane is about to be capturing the eclipse in about 13 to 14 minutes, so best of luck out there, and thank you so much for joining us.
It's my pleasure. Thanks so much.
So let's take a look at the telescope views right now. The partial solar eclipse has just begun in Spain. You can see a little slither of the sun that's been cut off on the one of the sides. The moon has just started to move in front, and will take roughly an hour or so before it completely covers the bright disk of the sun. Thank you again to our partners for these beautiful telescope views of the solar eclipse. We're about 10 minutes away from totality in Reykjavik, Iceland. The telescope views there are cloudy at the moment, but what we're seeing in front of us are views from Spain, and hopefully the skies stay clear for Spain. And fingers crossed, that is what we want for a total solar eclipse, is clear skies. So before totality comes, we have a few minutes to show you different types of science NASA has been conducting in Iceland for years. Iceland is a great place for astronaut terrain. A few years ago, the Artemis 2 crew and the science team spent some time there to prepare for the Artemis 2 mission. Let's learn more. Iceland is a really
wonderful place. It's a great place of interest for geologists, but it's also a wonderful analog. On Artemis, we'll visit the lunar South Pole, we'll make observations from orbit, and we have a whole new set of science questions that we hope that Artemis astronauts will help us answer for the Moon and Mars, which are, of course, planetary bodies we're really excited about for human spaceflight. Specifically for the Moon, we have features here in Iceland that are geologically relevant to the Moon, and also just have a sense of scale and a sense of identity that really mimic what we know the lunar surface looks like. There's a reason Apollo astronauts trained here, and there's a reason we're bringing Artemis crew here now. This is just a really wonderful place to learn about processes that shape the Moon and to really understand what it feels like and what it takes to actually navigate and do an EVA or a spacewalk on the lunar surface.
In Iceland, we are doing field work, we're training crew members. This is a key location for training for Artemis crews. Here we see in real time volcanic features that were created not long ago. It's a real special place for doing training for geology.
Here in Iceland, training the Artemis 2 crew in geology, there's really transformational science that we can learn by getting crews back on the Moon, getting samples back, and being able to do field geology with trained astronauts on the surface, making observations that only they can make from that perspective.
It's a fantastic place here in Iceland to be able to train geology. Also, navigation skills are another big component of what we're doing out here in a beautiful environment like this out here camping in the highlands of Iceland.
Wow, what an office to work in. So later on in our coverage, we're going to be taking a closer look at the student mooning experiments as well. And that's been taking place in Iceland for the past 24 hours. But now, we're going to be chatting with Marie Henderson, who is the Artemis 2 Lunar Science Deputy Lead. She has experience training in Iceland and has a key role in the Artemis 2 Lunar Flyby data collection. Marie, thank you so much for joining us.
Thank you so much for having me today.
So during the Artemis 2 mission, the astronauts were lucky enough to see a total solar eclipse from space. Not to be corny, but that's what I call sun and moon joy. Was that something that was planned from your side?
We knew that it was a possibility that we could have a solar eclipse during our lunar flyby. So months before, we prepared our lunar imaging procedures, some of that based on what we learned during the Apollo program, but also some that we learned from imaging that took place during the 2024 solar eclipse. And so we used that to prepare our cameras, but also once we realized we were coming up on a launch day, especially in April, where there was that possibility, we had to go back and we had extra time to train the crew on what they were going to be seeing during this eclipse and what types of observations the scientists were really excited to learn from that for.
Wow, what a lucky alignment of stars.
Yes.
Is seeing an eclipse from space any different from Earth? Did they see different things, and did they have to wear eclipse glasses?
Yes, the crew did have to wear eclipse glasses, and so we got those manifested, as you can see on your screen, for them to make safe observations. One of the large differences between what the crew saw as they went around the moon and from here on Earth is we looked at an eclipse through Earth's atmosphere, and so they didn't have to look through an atmosphere as they were going around the moon, so they were able to see the full extent of that corona as well as the zodiacal light in the solar system.
And how long was the eclipse up there?
It's about 53 minutes long, so they got a much longer chance to look at that eclipse.
Wow, what an opportunity. What was the day like for you in the sun?
It was a very exciting day. This was not something that we really knew exactly how it would be. And so we had just had a beautiful lunar flyby of the illuminated portions of the moon, and then we turned to watch this eclipse. And the descriptions that we heard coming down saying that they were, this is sci-fi, and they couldn't even imagine in this glow. We didn't see that in our coverage, but once those images started